Good evening, geometry, and welcome back. This week, we're starting our next unit. This unit is going to be looking at similarity, it's going to be looking at some triangles, but before we hop into those shapes and those ideas, we're first covering some math. That is algebraic proportions with multiplication and division. And so, what we have before us is a fantastic proportion 10 over x equals 6 over 5. What are we looking at? Well, we're looking at two division problems set equal to one another. So you may have seen in the past your teachers instruct you to do this with a series of shortcuts, with a series of strategies. Today, the way I'm going to instruct it, the way that I'm going to deliver this and try to help it make sense is by using the fundamentals of what we know about mathematics. Multiplication undoes division. And so everything I'm describing today can come back to that piece of understanding. And so I'm not going to be using any tricks. I'm not going to be using any shortcuts. I'm just going to be using that piece of fundamental understanding about mathematics. So while I'm doing this instruction, if you look at these kinds of problems and you feel confident and comfortable and you can solve them already, great. You are not obligated or forced to solve it the way I'm instructing right now. But if you feel like you get stuck, if you feel like that you're doing it and you keep getting the wrong answer, I will ask you to come back to watch this video, to try it again the way I'm explaining it, because 9 times out of 10, I can guarantee it will solve the problems you're trying to do. Worst case scenario, email me and I'll be glad to help you out. So let's solve this problem today. Ladies and gentlemen, with all cases of solving, we're trying to get x by itself. And so when we look at what's happening to x over here, our value of x is being divided by 10. So in order to solve for x, we want to multiply by 10. So we're going to do just that. We're going to take this problem and we're going to multiply by 10 on both sides. Multiplication undoes division, so 10 divided by 10 cancel out, just leaving us with our x left over. And on the other side of the equation, we have 6 times 10 divided by 5. Calculator genius, you're able to plug that in. A little bit of mental math helps us out here, or you can just do it in steps. 6 times 10, when you multiply fractions, you multiply the tops together and you multiply the bottoms together. Every whole number has a 1 underneath it. So 6 times 10 is 60 divided by 5. And when you do 60 divided by 5, that's the same thing as 12. So our value of x is equal to 12. Perfect. What did I explain there? Multiply by 10. And then from there, it's simplifying with multiplication and division. So let's take a look at another example. In this example, we have n divided by 4 equal to 8 over 7. So same kind of problem. Why am I picking these numbers? Well, to help illustrate why I'm picking these numbers, let's look at the previous example. One of the ways you could have solved this is by recognizing that 5 times 2 is 10 and 6 times 2 is 12. Multiplication and division. Proportions and fractions are all about comparisons. They're all about trying to find a proportional relationship, right? And so here, these numbers here don't have a easy connection like that. There isn't a proportional relationship that's obvious to see. 4 times what is 7? That's going to be a fraction and an ugly number. And so here's where the proportions I was talking about come in really handy. All the steps to solve this problem are the same as before. We want to find our variable, look at what's being multiplied and divided, and undo that. Solve that. But I want to really illustrate here that what I wrote is the exact same thing seen flip-flopped. So if you saw 8 over 7 equal to n over 4, well, that's literally the exact same problem, just written a little bit differently. And so the steps to solve are also the same. I'm going to go ahead and solve this second problem that I wrote just to help illustrate how you can solve it doing the same steps, just looking a little bit different. First things first, n divided by 4. We want to undo that by multiplying by 4 on both sides. So multiply by 4, multiply by 4. The 4's on the side with the n cancel out. 4 divided by 4 is 1. So we're just left with the 1n equal to 4 times 8/7. Here, a common mistake is to look at the 4 and the 8 and to think you can cancel it out. But because both the 4 and the 8 are on top, because both the 4 and the 8 are being multiplied, you can't cancel them out, you can't reduce it, you can't simplify it, because those are all examples of division. 4 times 8 is 32. And so you end up with 32 over 7. And ladies and gentlemen, that's where you got to stop. That's it. You did your multiplication. 32/7 don't simplify at all. 7 doesn't go into 32. So that's where you're done. Well done, guys. So let's look at another example here. In some of these proportion problems, you'll see your variable on the bottom. So let's take 7/6 equal to 5 over x. Ladies and gentlemen, the same thing I've described before is applicable here. Multiplication undoes division. So what are we dividing by? Well, in this problem, we're dividing by our variable. So how do we solve? Well, the first step is to get rid of that division. We can't solve for x if it's in the bottom. So we have to multiply on both sides by what we're dividing by. Ladies and gentlemen, we're dividing by x. So we multiply by x. We're dividing by x, so we multiply by x. And just like a number, because x is representing a number, just like with numbers, anything divided by itself cancels out. So on the side with the 5, x divided by x is 1 and cancels out, just leaving the 5 left over. On the other side with the 7 and the 6, x times 7 divided by 6, well, we can toss a 1 underneath it to help make it a little bit more obvious, but we multiply the tops together and multiply the bottoms together. So that just leaves us 7x divided by 6. And now we're in a position to be able to solve for x in a more familiar way. So ladies and gentlemen, once again, what are we multiplying by and what are we dividing by? Well, we are multiplying by 7 and dividing by 6. So ladies and gentlemen, I will always suggest to take care of your division first and to solve that division first in this kind of example, because then you're working with easier numbers. You're working with whole numbers rather than fractions. And so let's get rid of that fraction. We're dividing by 6, so multiply by 6. Multiply by 6 on both sides. The 6's cancel out on side with the 7, so that just leaves us with the 7x equal to 30. And now we're finally at a position that we're familiar with. We're multiplying 7 by x, so we divide by 7 on both sides. Our value of x is equal to 30 divided by 7. Is that a nice answer? Well, I'm pretty sure that if we complimented it, it would be pretty kind to us, but otherwise it doesn't really look that nice. 37ths doesn't have a nice ring to it or a nice even numberage to it. It's definitely a fraction. Definitely a fraction. But that's our final answer. That's all we can do with it. That's where we stop. And so, ladies and gentlemen, with that being said, let's take a look at one more example. This example is the same thing that we've been doing, except we are now looking at a problem where our multiplication and division isn't the only thing we're doing. It's the first thing we're doing, and I'm going to be bringing back phrases that I said earlier about multiplying by whatever's on the bottom. But it's going to be a little bit more complicated. Ladies and gentlemen, these problems have addition and subtraction within our fractions. And so this particular example is going to have z plus 12 over 4 equal to 7/9. Ladies and gentlemen, our goal is to solve for z. The first thing I need to point out is that 4 and 12 cannot be reduced here. We cannot simplify the 4 and the 12, and the reason why, even though there's division, is because the 12 is being added by z first. The 12 is being added by z first before we divide by 4. Another way I can say that is that everything, the z plus 12, the whole z plus 12 is being divided by 4. And so, if we want to solve for z, our goal is to get z by itself, so we want to undo our multiplication, our division, and our addition and our subtraction. Because everything is being divided by 4, just like in the previous problems, we're going to undo that division with multiplication. And so we're going to multiply by 4 on both sides rather than subtract by 12 because we're dividing everything by 4. And so multiply everything by 4 on both sides. The 4's cancel out. 4 divided by 4 is 1. And so that just leaves us with the z plus 12 equal to 7 times 4 divided by 9. And 7 times 4 is going to be 28. Divided by 9 is just that, 28 over 9. And now we have to take care of our addition and subtraction. Now, I know what some of you might be thinking. You might be thinking, great, we got to subtract by 12, we got to worry about common denominators and adding and subtracting fractions, but pause, soft, but a moment. Instead of subtracting by 12, we instead can solve this without worrying about the fractions at all, because of the same thing we've talked about before. We can undo division with multiplication. So rather than worrying about this 9 as a fraction, let's multiply by 9 on both sides to everything on both sides, which means the z and the 12 has to be in parentheses because the 9's being multiplied by everything, just like the 4 was divided and multiplied by everything. And now we'll be able to cancel out our 9's and solve this like a two-step equation. So the 9's cancel out on the side with the 28. 9 divided by 9 is 1. But on the side with the z and the 12, we distribute. So we end up with 9z plus 9 times 12, well, some mental math here. The 9 times the 10 is 90. The 9 times the 2 is 18. 90 plus 18 is 108. So we have 9z plus 108 equal to 28. Ladies and gentlemen, now we can solve for z. We don't have to worry about adding and subtracting fractions. We don't have to worry about getting common denominators. It's just a two-step equation. And we've done lots of two-step equations in our lives. So we can worry about the addition and subtraction, then the multiplication and division, and get the z by itself. So first, let's go ahead and subtract 108 on both sides. Looks like that I'm looking for a new color. So let's go ahead and pick some purple. Purple's a great color. So subtract 108 on both sides. That leaves us with 9z equal to 28 minus 108 is negative 80. Then divide by 9 on both sides. Our value of z is negative 89ths. So, what are the takeaways? Ladies and gentlemen, the takeaways are, with proportions, that you can always multiply by what you're dividing by, so you actually don't have to worry about fractions at all. So we multiplied by the 4s, that gave us the 28. Rather than subtracting 12, we multiplied by 9s in order to get this fantastic two-step equation in red, so we could just subtract, divide, and get our answer. Other takeaway: when the variable is in the bottom, you can still just multiply in order to get your variable on the top. Then you can multiply to get rid of the fraction. And from there, you're able to solve it just like you would any other algebra problem. So, ladies and gentlemen, when you are working through these proportions in this practice and you get to a point that you don't know quite how to solve, first, look for any division and undo it with multiplication. So, as always, if you feel like you get stuck, please email me. I'll be more than glad to help. I look forward to seeing you guys during our live sessions, and I'll see you later this week. Take care.